So in this video, we're going to talk about, we're going to define what a position vector is, and we'll talk about how, so a position vector we'll use in this class to determine the direction of a force acting between 2 points, for example, points A and points B. So if we have 2 points in space, so we have our x, y, z coordinate system over here. So let's say we have a point A and we have a point B. All right, we can define those points using XYZ coordinates. So for example, we can define point A as being with the coordinates x of A the coordinate y of A and then the coordinate or the length z of A. Okay. And in a very similar fashion, we could do the same thing for point B, where we could define its coordinates as x of B, y of B, and z of B. Whenever you're determining a position vector, you need to make sure that your xyz coordinate system are both for both the points that you're using have to be defined relative to the same origin. So for both these cases, x of A, y of A, and z of A, and x of B, y of B, and z of B should all be measured from our global origin system. All right. So what a position vector is it's defined as the vector that connects our 2 points of interest. So if we redraw our 2 points of interest, we have point A here, and we have point B. All right. What we can do is we just defined two vectors earlier. We'll call those our position vectors for point A and point B. So for point A, we'll have a position vector RA. All right, and then for point B, we'll have a position vector R of B. All right. So what we're interested in is the vector that will connect point A to point B. So just like we did in lecture 2, we're going to use a triangle, a vector triangle, or we're going to use vector addition to come up with our vector that connects point A and point B. Right? So if we look at this algebraically, what we end up getting is we get R of A plus RAB is equal to vector RB. Okay? So since vector A and vector RA and vector RB are both known already, we're interested in solving for vector RB. So what we can say is vector RAB is going to be equal to vector RB minus vector RA. Okay? So since we know RB and RA, we can let's rewrite them real quick. RA is going to be equal to x of A times the unit vector I plus x of B times the unit vector J plus y of A times the unit vector J and z of A times the unit vector K, and then for R of B we'll define it as x of B times the unit vector I plus y of B times the unit vector J plus z of B times the unit vector K. All right. So to get our AB, we have to just subtract the x, y, and z components from vector A to get the vector RAB. Okay. So you can just say RAB will be equal to the difference of the x coordinate of point B minus the x coordinate of point A times the unit vector I plus the y coordinate of point B minus the y coordinate of point A times the unit vector J plus the z coordinate of point B minus the z coordinate of point A times the unit vector K. Right? And that is how you can determine our position vector between any 2 points in Cartesian space.